Yes. Arrow is for pointers. When a structure variable is a pointer, we will use an arrow operator. When a structure variable is a normal structure variable, so we can use a normal structure variable, we can use a dot operator. When the structure variable is a pointer, we have to use a arrow operator. These are the two different operators that are used to access the members of a structure. Okay. Just a minute, the small delay. Sorry for interrupts. So here we are used a dot operator for normal, arrow operator for a pointer. So what is this statement called? What is this statement called? Function call. So what type of variable it is? The function call ampersand E1. E1 is a structure variable. Ampersand E1. So whenever the variable is sent through an address operator, that has to be dereferenced. Star E is a pointer structure variable created when you display the data using this star E. We have to use what type of operator it is? Arrow operator. When we are displaying through a pointer to structure variable, that is a structure pointer variable, this arrow operator that we have used to display the data onto the output screen. So this is about how we'll use a dot operator as well as the arrow operator. Okay. So is this concept is cleared thoroughly? So questions will be on these concepts only. First module, as I told in the previous semester, first module of your data structures will be basics of this pointers, arrays, and memory location. Any doubts is there, please feel free to ask. So I'll repeat it once again. If any clarifications are there. Okay. If there is no clarification, I'll go with the next concept, pointer arrays. So pointer arrays are nothing but an array of pointers. Sometimes we call it as array of pointers. Okay. So this is a normal array we have created. Integer a of 4, 10, 20, 30, and 40. All the 4 variables, that is the data values stored there. So 10, 20, 30, 40. This is the memory locations of the array variable A. This is the array variable A 2000 2002, 2004, and 2006. These are the four different variables with addresses. So this is one simple array we have created. So a pointer variable p is pointing to a first address of a array. Pointer is pointing to the first address of the array, that is 10, that is 2000 is the address A0. By default, this is for an individual element addressing. If pointer is equal to p is equal to a ampersand a of 1, if you put directly, it will going to point to the first element of an array. That is first element of a of 1 for the 20, that is 2002. So default, there is one more condition you should be careful. Default, when you put it as pointer p is equal to a, by default it will go into point it to the first element of an array only. When you mention the index specifically to the concerned index value, that pointer will be pointed. If not, p is equal to a, ampersand a naught, ampersand a1, ampersand a2, a3 up to an. So that is nothing but individual elements we are assigning it to a pointer. P is equal to a means what? When we call p is equal to a, only a if you mention, what it will assign is my question. This I thought also for you people. Not the starting address. Starting address ampersand a naught also we can put it, right? So P is equal to A, general. Recall your previous semester pointers, what I explained. Just recall once, 1 or 2 minutes of time I will give. Recall by yourself. P is equal to A. So majority of students have forgotten, I think. P is equal to A. What we call that? P is equal to A points to the first element of array A. Yeah, just now I told that there is one specific meaning for that P is equal to A. Assigns all the values of A to P. Yes, correct. Kavya, it is correct. All the values, that is all the data values, that what which is stored in an array which is assigned it to p, but by default it will point it to the first element of array only, but the whole array is passed as a parameter or data to the pointer. That entire array is assigned to a pointer variable called p. Now is it cleared, all of you? Now is it cleared for how this p is equal to a? Yeah, good. Okay. If it is cleared, we'll go with the next concept with the program. See ya. P is equal to a. P is equal to A. So pointing to the first element of a array. Here, standard io.h, this files and all already known. Array is created 5, 10, 15, 20. Pointer variable, indexing, p is equal to a. So first iteration, I is equal to 0, 0 less than 4, condition is true, get inside to the loop, print first value of an array, star p. Star p will point to the first element of array, sorry, this array, not that array, we have changed the array elements. First element of an array, 5 will be printed. Okay, so next, perform increment of p plus plus. What is this p plus plus called? Any idea? Why we have to increment that? Yes. Why p plus plus required? I plus plus, we know that indexing of the for loop is incremented. What is p plus plus called? Pointer points to the next address, that is p plus plus pointer to point it to the next address to display that concerned value. The value of p has to be updated. Yes, fine. So the next value, that is 10. So same way 15 and 20 will be displayed it on the output screen. This is how a pointer variables are used for array of pointers. P plus plus is executed in the for loop. Pointer to the next address in the array. So there only I have mentioned. So each and every point you can see that below to the here. See the statement what I have written there. So everything with clear explanations I have mentioned it over there. Okay. So no need to worry that. Is it cleared for all of you? Okay. Hmm. Oh, I think this is done. So for the today's class, this is completed. I'll add one more presentation. Just a minute. Yeah. How many of you have heard memory allocation? What do you mean by memory allocation? Adding memory. What is that adding memory called? Memory allocation is nothing but assigning the memory to the variables or to the data variables or functions and so on. Assignment of memory. Yeah, correct. So here, two types of allocation is there. The first part is called static memory allocation. The first part is static memory allocation. Second part is dynamic memory allocation. Static memory allocation and second part is dynamic memory allocation. These are the two different parts of memory allocations we have. So static allocation, there's a fixed size that already we have known. So here, the dynamic memory allocation, this is one more function called dynamic allocations. So in this dynamic allocation, with different types of functions, we can explain this dynamic memory allocation functions. Okay. So what are those functions? What are the different dynamic memory allocation functions we have? So first one is malloc. General definition of dynamic allocation is allocating a memory during execution time or run time. Allocating the memory during runtime or execution time. So that we call it as dynamic allocation. So here some of the functions or methods we have to allocate a memory dynamically. A first function called as malloc, second one calloc, third one realloc, fourth one is to delete a memory. Whatever the memory which is allocated, if you want to remove that memory, that is delete the memory, that free function will be used to reallocate the memory. Okay. So this is about different types of allocation of memories. So here, first method, malloc. What the general malloc indicates. So today I will give a brief description. Next class I'll explain the step by step, one by one, the functions with complete description. Okay. First method is called malloc. Generally, malloc M stands for a memory allocation. As we have seen, M stands for a memory allocation. Malloc M stands for memory allocation. So through pointers only, we have to allocate the memory dynamically. Second one, calloc. What is this calloc called? Anyone? Malloc memory allocation, I told. Calloc, contiguous allocation. Aryan, good. Somehow we are remembering the previous concepts. Very nice. Calloc, whereas T stands for contiguous allocation. So the third one is that is reallocation of a function. Why realloc is used? Why the reallocation is required? If the allocated memory by malloc or calloc is not sufficient, if the memory allocated is not sufficient, we will go into use with the realloc function, that is reallocation. So, but to reallocate the memory, we should go with the previous allocation. We have to check first, then we have to reallocate the memory. Okay, so this is about memory allocation functions: malloc, calloc, realloc, and free. So these are the four different memory allocation and one deallocation function. Okay, is it clear? Basic definitions, is it clear? I'll be explaining these functions in detail. Now, Tej, so this is a brief description I have given of each and every function. It takes one complete class for each functions. One by one function, I'll explain it in the next classes. Okay? So because the time is not sufficient, 5 minutes, I cannot explain that complete concept. So it takes another lot of time. Okay? I will explain that completely. Any other doubts is there? As of now, a 5 minutes of time I will give. Any clarification or any doubts is there, you can ping it fast. Once it is completed, then I'll start taking the attendance.